Hello students, welcome back. In this video, we're going to begin building Astro, a physics-based survival game where a drifting probe must navigate through a field of incoming asteroids using only thrusters and momentum. Players will fire their thrusters to control the direction while managing fuel and avoiding incoming asteroids. Movement is not instant. Every action will carry momentum and require careful control. As the game progresses, asteroids will spawn faster and faster and move with greater speeds. Fuel will become harder to manage, and every mistake will compound until all control of our probe is lost. So let's head to the computer screen and let's dive right into Astro. So I have a web browser open here, and I am going to go directly to the web-based IDE that we'll be using, which is vscode.dev. In here, we're going to open up a folder directly, our Astro folder that we've downloaded. So I'll click Open Folder, and I'll head to my desktop, which is where my folder lives, and I'll find my Astro folder right here. Oh, and I will open the entire folder. I won't go into the folder, I'll actually select it. And so we will allow that. And you can trust the authors. I trust me. You can trust me here. And so what we have now is 8 lessons that we will work through to take our broken, incomplete version of Astro and finish it together. So let's open up lesson 1. And in here, you get 2 files. For every lesson, we're going to get 2 files. We're going to get a starter file and then the final version of the file. So the final version has all of the code that we are going to write together here in this video. And I want to give it to you so you can reference it on your own. You can go back and look at this if you need to. If you made a mistake or if you missed a line and you want to double check your work, you can always come back and reference the completed version right here. But we are going to work together to learn a little bit about game development and JavaScript in our starter file. So I'll make sure that that is open. Then I'm going to minimize our browser tab and I'm going to go to this folder directly here on my desktop, Astro, and we are going to open lesson 1's starter file in the browser. So now any changes that I make here in my code, I will be able to see. So here is our game right now. This is supposed to be some like probe drifting through space. I don't know what kind what this looks like. It looks pretty bad. This is like a weird lima bean green color. There's this weird blue dot that is sort of tracking my mouse-ish. I don't know. And there's this thing that's in the center of the screen. I don't know. This just looks pretty bad. It says game name, orient thrusters by moving our mouse. We got some type of mouse movement, but this seems unplayable. It's broken, and it does not look good. So we are going to have to head to the code over here to fix all of those issues. But before we do, let's just take a look at what this file is and what is available to us in this file. So the first thing that we'll note here is we have a .html file. So an HTML file or hypertext markup language file is the language of the internet, okay? Basically, all of our web content can be created through HTML files. We don't need to know much about HTML files, but just know that it is made up of a sequence of tags. And so a tag is something that is inside angle brackets, and we have all different types of tags. Here's a head tag, a title tag, a style tag, and when you open a tag, so here's an opening of the tag, we can put content inside of that tag, and then close the tag. So typically we have opening tags and closing tags. So you open, you close. Some tags are self-closing, but we don't need to know too much about that. The content that we put inside of this tag shows up on our website. So right now this says Astro inside of here. I'm going to change that to Mike. That's my first name. And so let's go back to my game now and let's see where that content might change. So if I refresh the page, right here up in the tab, the title of my tab now says Mike, which is a terrible name for a game, if I don't say so myself. So I'm going to hit Control-Z to change that back to Astro. So now let's look at a tag right here. We have a script tag. So we open the tag, we close the tag, and it looks like there's nothing inside the tag. There's nothing here. Well, this tag is for JavaScript. Okay, JavaScript is going to be the programming language we use to create our video games. But here we're not writing any JavaScript. Instead, we are importing or bringing in a library of JavaScript that is pre-written. And the name of the library that we are going to work with is the P5 JavaScript library. So P5. The P5 library is a really great library for rendering graphics to a web browser. And we have a lot of graphics that we want to render. If we look at this game, we want to render, I'm assuming this is like my little probe, okay? We want to render I don't know what this blue dot is that's following me. It's probably my thrusters. We want to render our space background and our text here in the HUD. All of those things need to be displayed to the screen, and the P5 library is going to help us do that. It's going to bring in some functionality that we can work with. All right, so let's scroll down a little bit more. What else we got? We got like a style tag, and then something called a body tag. Oh, and then here's another script tag. And it looks like we open the tag. Where do we close it? Well, we close it all the way down here. So if we look, all of the JavaScript code that sits in between that opening and closing script tag, that's our video game. That's the code that we are going to write, that we are going to work through and solve each of these missions that you are seeing to take this ugly, ugly, broken game, in case you forgot what it looked like, and turn it into something much, much, much better. So let's go up here to the start of that tag, and let's see what we're going to get inside of our JavaScript tag. So it says Astro Lesson 1, the world and player. So the scope of our video here for this first lesson is we are going to build out our world. What is the aesthetic we want? How do we want our game to look and feel? What kind of mood are we going to try to convey to the person playing our game? And we're going to work on our player object. The user that's playing the game has to have something that they can control and use to interact with the world around them. And this is going to be our player ship, which is like our little probe. And then we have a mission checklist. So we're going to go through for our lessons and solve 8 missions all together. Each mission is going to be a small isolated part of code that we are going to fix or write together, and it should cause us to see visible changes or have tangible gameplay changes to our game. So let's go through now, and if we look, just below that, we get something called the student edit zone. The student edit zone is pretty important. These are places or variables that you can go ahead and change. You can change them and you will not break the game. All right, these are like, think of these like knobs or dials that you can tune to change how the game looks, how the game plays, and how the game feels. And so feel free to go through and change anything here in the student edit zone. We've got, I'm thinking variables here. We've got something called a color palette. So these are like our colors, but then be careful. There is an end of the student edit zone. Once you go outside of the student edit zone, and we're going to take you out there in some of our missions. If you don't make changes correctly, you could potentially break your game. So be a little weary of what you're writing out here, because we don't want that to happen, right? We don't want to find ourselves in a position where our game is broken. But if you do, you just come right back here to the completed files, and you can reference those lines and fix them yourself. All right, so let's look. It looks like we then define some gameplay variables. So it looks like I have a variable called player and stars. Okay, we'll talk about that. And then we get into functions. So we are going to write our games using functional programming. We're going to have a bunch of different functions. And you can think of a function like just a set of instructions that we want to run. So if you look here inside of this function, which is called setup, I have 3 lines of code. Now imagine I wanted to run these 3 lines over and over and over again. I'd have to type out 1, 2, 3 lines, then another 3 lines, then another 3 lines. But because they are in a function, instead of typing out those 3 lines, I can just run my function, which is going to be 1 line. So running the function would execute all 3 lines of code. Running the function again would execute all 3 lines of code. Running the function a 3rd time would execute all 3 lines of code. And so you can see right here we have a function called setup and a function called draw. These are very important functions, and I want to highlight them because these are part of that P5 JavaScript library that we imported at the start of our HTML file. So these are given to us, and they do 2 very important things. The setup function runs once automatically at the start of our game. So right now, if I hit the refresh button, as soon as the page loads, the setup function gets run. And what is the setup function doing? Well, we are creating a canvas. Think of a canvas like the thing that you are seeing right here that our game is going to be drawn on. We set our font for the game, and then it looks like we are calling some function reset game to defaults. And if you look, that's just below down here. All right. And so that runs once at the start of our game. this next function called draw runs every single frame of our game. So this runs repeatedly. So imagine if my game is running at 60 frames per second, that function gets called 60 times in 1 second. And it gets called 60 times the next second and 60 times the next second, over and over and over. And that functionality is built into our P5 library. In our draw function, it looks like we are calling a function called update thruster direction and a function called draw scene. All right, so these are provided to us by the P5 library, setup and draw, and we can put whatever we want in them. But all of these other functions down here are our own personal functions that we have written, or I have written and given to you. So we have one called reset game to defaults, and we'll look a little bit more at these. Update thruster direction. We've got draw scene, which has draw background, draw player, and draw HUD, and there are those functions. Okay, so it looks like, and then we hit the end of our JavaScript tag. So I want to break down a key idea here in our game development process that we're going to be looking at. There's really 3 levels to this, okay? 3 levels. So look at some of our functions. We got draw, 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 draw. It looks like we have a lot of functions that draw things, okay? So drawing is going to be exceptionally important. We also have update. So it's important that we're updating things. So one of the levels of game development is we gotta draw data to the screen. Another level is we have to update that data. And then the third level, which isn't really inside of a function at all, but it's really like our student edit zone, we have to define the data. So look here, there's going to be a variable called star count, which is equal to 30. So game development, at least how we're going to approach game development, is going to have 3 levels. We have to define our data, we have to update our data so we can change it, and then we have to draw the data to our screen so we can actually go through and see it. All right, with all of that said and all of that under the way, let's go back to our mission checklist and let's actually take this terrible, terrible state of our game and make it substantially better. So the first thing we're going to do is we're going to look at mission number 1. Mission number 1 asks us to change the background color of space. Yeah, because I don't know about you guys, I don't think space is a lima green color. At least not the space that not the space I look at. All right, so where do we go to do this? Well, we could kind of like scroll through the code and search for things, but I'm going to let you in on a little tip here. We have a mission 1 tag. This phrase, mission 1, only appears one other place in our whole program, and it's exactly where we need to go to target our code. To find that, we're going to hit Control F on the keyboard, and that opens up a nice little search bar right here. If you have text highlighted and you do it, it will auto-populate it right there. But if I just am like clicking off the screen and I got no text highlighted, if I hit Control F, it pops it right up. And now I can type the name of the tag I'm searching for. Mission number 1. Mission 1. All right, so it highlights it right there, and it tells me that is one of 2 instances of the mission 1 tag. To find the next one, I just hit the down button right here. So I can actually hit down or up. I'm going to go down. And boom, look at that. There is mission 1 where we want to change the background color. It says change the background color of space and observe how it changes the mood of the world. Now, before we go ahead and do this, let's think about the context of where we are in our program. These look like maybe values that we can change and adjust to tweak how our game looks, plays, or feels. If I scroll up a little bit, I think we are inside. We are smack dab in the middle of our student edit zone. So these are safe to modify, so we can have some fun here. So right now, let's look, it says const BG color and then this weird looking thing. There are 3 things going on. Actually, there's 4 things going on here, and we're going to quickly talk about each of these. First, we're declaring something as a const or constant. That means over the scope of our program, the value that we put as our background color is not going to change, all right? Over the scope of where this variable, and this is a variable, BG underscore color is a variable that holds a value. Our value is right here. Its value is not going to change at all. And we are assigning a value with a single equal sign. So we've got this constant called BG color, and we're setting it to this weird looking value inside of quotations. Now, when something is inside of quotations, that is known as a string. A string is anything that is inside quotes. And we have a special type of string that starts with a hashtag or a pound sign. And this is known as a hexadecimal string. All right. So this is a hexadecimal string, hex string. And hex strings can be used to define colors. Now, if you look here, we have A3B744. What in the world? Well, let's think about regular numbers. Regular numbers, if I started counting, and I'll start counting at 0. I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I have 10, and then 11, and then 12, right? If you think about it, these are my digits, 0 through 9. I run out of digits, so what do? Well, I just put a 1, and I start over. So 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. It makes sense, right? That's counting. But we have other number systems that we can use. This is known as a decimal number system, which has 10 digits, 0 through 9. A hexadecimal number system has 16 digits. Okay, so let's think about what they are. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But then I have another digit. I have the letter A, and then I have the letter B, and then I have the letter C, and D, and E, and F. So there are my 16 digits, but then I run out. So what do? Well, I just start over. Just like we did here, I put a 1 in front of it. So 1, 0, and then 1, 1. So this is known as hexadecimal. It's the characters 0 through 9 and the letters A, B, C, D, E, and F. And we can use hexadecimal to define a color string that is two numbers that are a red color. So right here I have A3. That is my red channel. Oh, get out of there. That is my red channel. And then I have two more numbers, B7, and that is my green channel. And then I have two more numbers, 4, 4, that is my blue channel. And so we can build colors for our computer screen using any combination of red, green, and blue. So what is the smallest number we can get for a red value or a green value? The smallest number is 0, 0. That means don't give me any red. Don't give me any red. What is the largest value we could have? The largest value we can have is FF. That gives me all of that color. So this would be all of the green and none of the red. And 0, 0 in hexadecimal, that corresponds to just what we know as 0. And FF corresponds to what we know in decimal numbers as 255. So that's a bit of a big jump. We just learned a lot right there. But let's see how it all applies to this little value right here. If we look, I am saying, hey, give me a good amount of red, like A3 is a fair amount of red, okay? B7 is even more green, and then 4, 4 is not a lot of blue. So I have a fair amount of red, a lot of green, and a little bit of blue. Red and green sort of make like a yellowish color. So that's kind of right. I feel like that looks pretty good. I'm going to delete all this so we don't crash our program, and let's mess around with some things. Let's do all the green. Let's see what happens if I do all the green. So all the green is going to be, those two numbers are going to be FF. And so now if I refresh my page, whoa, it's more green. That sort of makes sense. We upped the amount of green. Let's lower the amount of blue. So I'm going to put 0, 0. Give me none of the blue. All right, it's even more green. And let's do all the red, So now I have all the red and all the green. Ooh, that makes yellow. All right, so red and green mix to make yellow. What if I bring in all the blue? So now I say, give me all the red, all the green, all the blue. What do I get? Ooh, well, I get white. So if you mix all of your colors in equal proportion, you get white. What if I say, give me none of the red, none of the green, and none of the blue? What color would that make? So 0, 0, 0, 0. Ooh, I get the darkness of space. I get a nice black color. So that's kind of cool. In fact, that we might land there. I think I sort of like that. But I want to give a little bit of color. So why don't I do like 0, 8 in the red channel? That'll give me just a slight bit of red. Let's give a little bit of green, 1, 1, and a little bit of blue. I'll do 1F. And let's see. So this is going to give me just, ooh, I like that. That sort of creates like a nice navy color there for me. A little dark, but present. So I'm really happy with the background color that we have right there. Awesome. I think mission 1 is done. So that means we can move on to mission number 2. Mission number 2 says we got to increase the star count to thicken the star field, because right now, I mean, there's a decent number of stars, I guess, but I think I want more. I want more stars. So I'm going to hit mission 2 in my tag finder here, and I'm going to go down. And mission 2 is all about this star field structure. So we want to increase the star count value to make the world feel denser with more stars. So look, we've got 3 more constant variables that we can mess with: star count, star size min, and star size max. So right now our maximum star size looks like it's at 10, our min star size is at 1, and our star count is 30. So I don't know, let's just up this. What if I say, like, give me 200 stars? Is it actually going to go through and do it? Whoa, look at that. That's a lot of stars. I think that's too many for me personally. It sort of looks like overwhelming. I'm going to lower the star count to be like 70. I'm going to do 70 stars. Let's just see. All right, so that looks pretty good. Let's mess with the size of the stars a little bit. Let's have some fun. Let's make the maximum size 100 and see what happens here. Well, now they don't look like stars at all. They just look like big circles of white. Let's change that. I'm gonna make it. Let's do smaller stars. I want my maximum size to be smaller, so I'm gonna set it to 4. So let's do 4. Oh, and that looks really good. They're like sort of off into the distance. So I'm really happy with that. All right, I think mission 2 looks pretty great. Now you might be saying, okay, well, where are these stars like coming from, right? How are we getting them, right? We just changed a number here, and the magic happened. So let's just scroll through really quick. Let's just see if we can see why the magic happened. So if I run through here, okay, it looks like we have some variables here. A variable called player. And we'll talk a bit about that. And then we have a variable called stars, which is something known as an array. Those square brackets mean it's an array, and that is a container that can hold a bunch of stuff. So I bet that's going to hold a bunch of stars, and it looks like we're holding the stars right here. Where are we calling this? We're calling it inside of the reset game to defaults function. So whenever we run this, and when do we run this? Remember, it's being called here in our setup function, which is one of our P5 default functions that run as soon as we reset the game. Watch. If I comment this out, are we going to get any stars? Let's see. No stars at all. Nothing. So that's we just destroyed space. Let's get space back. All right, so now we're calling that, and you can see right in here we're creating a bunch of stars, and it looks like there's our variable star count that we just looked at. But this is another mission, so we're going to save that, but we're just previewing where we're headed. Mission 2 is done. Let's go to mission 3. We want to make the player's ship larger. All right, so if I go to the mission 3 tag, our player size, it says increase the player's radius value to make the ship larger. So you can see, well, let me refresh. Let's get those stars back. There we go. Our ship, right, our little probe is a circle. So how do we define the size of a circle? Well, there's a couple of ways we can do it. We're going to do it by defining a radius. So let's make this radius big. Let's make it 100. We'll make just the biggest player ever. All right, so there is our player. So you can think of the radius as the distance from the center of the circle all the way to the edge of the circle. That is the radius. And if you take that radius and you multiply it by 2, what you get is something known as the diameter, the distance across the circle passing through the midpoint. And so those are going to be important values for us as we talk about how our player, which is a circle, interacts with other objects. Now, remember, the whole scope of this game is for this ship to avoid asteroids. If we make the ship this big, I don't think they're going to be avoiding anything. Our maneuverability is going to be shot. So 100 is way too big. Let's make it 20. Let's see what 20 looks like. Is that going to feel good? I think 20 feels pretty good for me. So I like 20. I'm going to stick with 20 on that. All right, I think mission 3 is done. Our player's an appropriate and good size. So let's look at mission number 4. Ooh, this is our player's visual identity. We're going to change the player's color and give the ship a brand new visual identity. It looks like we have 3 colors. We have the player body color, the player accent color, and then the player thruster color. All right, well, let's look at this first one, player body color. So the player body color, 3-5, B4, D3. So it's got very low amounts of red, and then a lot of green and a lot of blue, even more blue. So green and blue, when you mix them together, are going to make cyan, and that's going to be this color right here. I don't really like it. I'm going to change it. And you can change this to be whatever you want because you are inside of the student edit zone. This is where you can change things to change how the game looks, feels, or plays. So right now we're targeting how things look. So find something that looks good for you. I am going to do something of the following. I kind of want the body to be more like a whitish color. So I'm going to do D7 in the red channel. I'll do E3 in the green channel, and I'll do F4 in the blue channel. So that's going to be a lot of color, and that gives me like a nice sort of like soft white. I really like that. But I don't like the accent color, and I think that's the accent color right here. That doesn't work for me. And if you look, we have all of the red, a little bit of green, and then a fair amount of blue. So red and blue are going to make like a purplish pink color, and that's exactly what we're seeing. So let's swap that out. I don't like that accent color. I'm going to go with 4-9 in the red. I'm going to do E1 in the green channel, and then give me all the blue you got. FF in the, not FR. FF in the blue channel. So let's look at what color that looks like. Ooh, that's sort of like that cyan that I had on the outside. I like it on the inside. So that's what my little probe guy is going to look like. Now, if you look, I got this weird blue dot that just keeps chasing me around the screen. I think that's something to do with our thrusters, because if we move our mouse, it says we'll orient our thrusters. And as I move my mouse, that thing sort of moves. So let's change its color, because right now, look, it's got mainly blue, and that's what I'm seeing. So I'm going to make it so that this is a thruster, right? It should probably be like, I don't know, red or yellow or orange, indicating like fire, going out as we fire our thrusters. So let's do all of the red and then a fair amount of green. So I'll do like B3. So this is going to give me like that orange yellow color. And then we'll put a bit of blue here as 4-7. So FF B3 4-7. And if we run this now, ooh, that looks great. Now that looks like it is more thruster worthy to me. The only thing I don't like is that the thrusters are not attached to the ship. Look, they just kind of like, they're floating out here in space. They are moving, but not in the ideal manner that we want right now. If we find ourselves in space with our thrusters way over here, away from our ship, we are in trouble. SOS. All right. So mission number 5, it says input connection. All right. Ooh, look at this. It puts us in a function called update thruster direction. All right. Before we go and look at mission number 5, I always like to get an idea of where we are calling functions from. So we're working in a function called update thruster direction. Now, if you look here, we had mentioned at the beginning of this video, we have 2 special functions that are brought to us by the P5 library. We have setup, which runs once when you start your game, right? So when I refresh the page, boom, setup just gets called. Setup just gets called. Look, I get randomized stars. Perfect. Now, the draw function runs every single frame of our game. So if I'm running at 60 frames per second, it's 60 times a second. These functions get called. And in here, we are calling update thruster directions and draw scene. So this function that I'm working in for mission number 5, and I'm going to jump back down to it, is getting called every frame of the game. So let's look at what we're doing in here. It says, okay, we want to use the mouse difference values to set the ship direction and complete the distance math for normalization. Whoa, there's a lot we got to talk about here. In fact, this is pretty high level stuff. We should probably go to my whiteboard so we can talk about the math behind it. Okay, so let's head over to the whiteboard and we're going to dive right in. All right, so I think our end goal here is, if this is my player, right? Here's my orb, and I have these thrusters, right? Let's just say like I want to have a thruster and my thruster's here. So that might mean my mouse, and I'll make my mouse an X, right? If my mouse is over here, I want the thruster aligned right there. But if my mouse is, say, over here, right, I want the thruster to move and position itself. And if I put my mouse over here, I want the thruster to move and position itself. And if I put my mouse way over here, I want the thruster to move and position itself. So it always knows exactly where the mouse is and adjusts itself to the correct location, because we're going to have sort of like mouse-based controls here. So how are we going to go about doing that? Well, the first thing that we got to do is we got to figure out where exactly is the mouse in relation to the player. So our player, and our player has a central point. So here is our player's central point, and we'll say here is our mouse's central point. All right. So let's take that as our example and let's expand it out a bit. So I'm going to say, okay, here is my player, bloop, and here is my mouse. Okay, so mouse and player. Now, if we look, we are a certain distance away from each other. And I'll represent that distance right here with this arrow. And I'll call that distance our length. That's the length we are away from each other. So how would we determine that? Well, if we think about it, our player has an X position and a Y position. So I'll call it like, okay, there's like PX and there's PY. And so does our mouse. Our mouse has an X position and a Y position that live in the game. I'll call it like mouse X and mouse Y. And if I can figure out the difference in those X values, I can determine how far away we are in the X direction. I'll call that dx. And if I can determine the difference in the vertical values, I know how far away we are in the y direction. I'll call that dy. So let's just look. dx will be the mouse's x position, so I'll call that like m dot x, minus the player's x position, p dot x. dy will be the mouse's y position, m dot y, minus the player's y position, p dot y. So we can easily figure these things out. The mouse is x, the player's x, the mouse is y, the player's y. So we now can solve for dx and dy. I know this side of this triangle that I have here, and I'm going to name that triangle side A, and I know this side, I'll name it B. Well, what would we name our third side? This third longest side of our triangle, which is known as a hypotenuse of the triangle, I'll name C. And there's a really nice relationship in math, in trigonometry, for right triangles like this, known as the Pythagorean theorem, which says if you take A squared and you add B squared, you get C squared. So our goal here is to determine the length variable, how far away the player and the mouse are. So we can get this by taking our A value, dx, which we know we can solve for. So I'll do dx squared plus our B value, which is dy, which we know we can solve for, dy squared, is equal to our C value, length squared. But I don't want this length squared. I want to solve for the actual distance between the player and the mouse. So I got to get rid of this squared right here. The way we do that is by taking the square root of both sides. So taking the square root there, those cancel. And so I'm going to get the length is equal to the square root of dx squared plus dy squared. All right, so how is that going to help us determine the direction we need to orient our thrusters? Well, now that I know the length, I can use that with something called an angle. And so there's this like angle theta here, all right, between the length and the dx variable. And as we move our mouse, so imagine I move my mouse up here now, that angle would change. So now my length, beep, is way up here, and I'd get a different angle. And we can figure out the portion of this arrow that is horizontal and the portion of this arrow that is vertical by looking at the ratio of dx divided by the length and dy divided by the length. These are essentially some trig functions, and maybe you've heard of them, known as the cosine of theta, the cosine of our angle, and the sine of our angle. Essentially, they're just telling us how much of our arrow is pointing in the x direction and how much of our arrow is pointing in the y direction. And so we're going to use those values, these cosine of theta, how much of our arrow is pointing in the x direction, and the sine of theta, how much of our arrow is pointing in the y direction, to help us figure out the direction we have to put our thrusters in. So let's take all of that math now and look at it in the context of this function. So inside update thruster direction, it looks like we're getting a dx variable. We're taking the mouse's x value and subtracting the player's x value. We're getting a dy variable, the mouse's y variable, and subtracting the player's y property. First off, we gotta go look at this player, I think, because if I scroll up, here's our student edit zone. Right outside of the student edit zone, we saw this earlier, we have this thing called player, and this player is inside curly brackets. That makes it an object, all right? And objects have properties. These are things that are specific to this variable. So this player has a property known as x, a property known as y, a property known as vx and vy, and nx and ny. So what are these things going to do? Well, we can access these properties, we can change these properties, we can read these properties. X and Y are the player's position in our game world. Now, X position of 0 is up in the left as the left side. Y position of 0 is at the top. So right now the player would have been at the top left. So why is he not appearing at the top left? Well, if you look here in our reset game to defaults, we are updating those player properties. The X position is width over 2. The Y position becomes almost like center of our canvas, our height over 2. So we're changing those properties. So now what we need to do is we need to target those exact same properties to determine how far away our mouse and player are. So we're doing that, right? We're taking mouse's X minus the player X, and that is dx. Mouse Y minus the player Y, and that is dy. And that was exactly what we wrote about here in our drawing, okay? Dx and dy. Then we are setting a variable called len to 1. I don't think that is right. In fact, I'm pretty sure we said that the length we would use something known as the Pythagorean theorem. It is the square root of dx squared plus dy squared. I think that is the magic. And if we look, if that length is at least greater than 0.00000001, so as long as it's essentially like not 0, and the reason why is you don't want to divide by 0, that would be bad. We're taking player.nx, which is one of the properties we saw of the player, and we're making it dx divided by length. What is that dx divided by length? That dx divided by length is the cosine of our angle. It's essentially how much of the length or our distance away from the player and our mouse points in the x direction. And then we're doing something similar for ny. All right, so that's how much points in the vertical direction. And we have those in our properties. So let's see if I refresh the page now that that's fixed. Oh, look at this. Now my player, oh, this is kind of interesting. My player, the thrusters are at least bound to the ship, right? They're not zooming all over the place anymore, but it looks like they're only moving in the x direction, right? If I move vertically, they're not moving. I'd like this thing to sort of circle. So you can see it is sort of following me horizontally, but this should be like down here at the bottom of the ship, and it's not right now. So something else is broken with this system, but we are well on our way to fixing it. So let's look at mission number 6. Mission number 6 puts us in the draw player function. All right, so this is all about drawing our player. It looks like we need to use the nx and ny properties to position the thruster. Make the thruster follow the mouse direction. All right, so in our draw player function, where are we calling this? Oh, right. We have a draw scene function where we draw our background, draw our player, draw our HUD. And so we're drawing our player. Let's talk a bit here. The first line says no stroke. That means give me a marker that is invisible, so you don't see the outline of the shape that I'm about to draw. And then we call fill. And we fill our paint bucket with a specific color of paint defined by the player's body color. Then we draw a circle. And when we draw a circle, it takes 3 pieces of information: the x coordinate of the center, the y coordinate of the center, and then the diameter of the circle. So we're taking our player's radius and multiplying it by 2. All right, so we do that for our body color, for our accent color, and we're seeing that. There's our body color, there's our accent color. The accent color is a smaller circle. Yep, and our diameter is smaller. But now we got to fix the thruster's direction. So if you look, the x value is working. So how are we doing it for our thruster x variable? It looks like we're getting the player's x position, and then we're adding that nx property, which was the portion of our length arrow that was in the x direction, and multiplying by the player's size. Well, in the y direction, for our thruster y variable, we're not doing something similar. We're just saying it's like player.y. So I think we need to take the player's y position and add to it the portion of that length arrow that was pointing in the vertical direction. So that is the ny property that we had solved for. And I'm going to take that and multiply by the player's radius, because I want this to go right on. I want my thrusters to always be on the edge of the circle. So the edge of the circle is going to be 1 radius away from the center. I think that's all we need to do, because then we put a new color in our paint bucket, our player thruster color, and we're drawing another circle. This time, this circle is going to be at thruster X and thruster Y, our values that we calculated right here. And it's a nice teeny tiny circle. So let's take a look. Let's refresh the page. All right, so hey, look at that. We have tracking now for our mouse. So we're following our mouse movement quite nicely. Mission 6 in the books. Let's go to mission 7 here quickly. It says keep stars out of the HUD area. Is that a problem? Oh yeah, look at that. Our HUD, which is this area up top, which should really only be for text, it's got stars in it. You can see the stars behind it. Now that's interesting. You can see behind the HUD. Why is that? Well, if we look in our color palette section, my HUD background color, so this is up at the top, is not defined as a hexadecimal string. Instead, it's defined as an RGBA string, RGB alpha. So this is another way we can define colors, and I typically do it anytime I need a transparent color. So an RGB alpha string takes 3 numbers for the red channel, the green channel, and the blue channel. But this time they're the numbers 0 through 255. So 0 means give me none of the color, and if you hit 255, it means give me all of the color, much like 00 and FF. But it's the last number that is our alpha channel, or our transparency. This is a number between 0 and 1. If you set it to 1, like I'm going to change this, that means it is not transparent at all. You are not going to be able to see behind anything, and we can't see behind it at all. If you make it closer to 0, it is extremely transparent, and you are going to see behind it quite a bit. In fact, it's like almost not visible at all. And so oftentimes we'll tweak that value. I have a transparency of 0.65, which means see behind it a little bit. And what I'm seeing is all of these stars in the HUD. So I got to fix this for mission number 7. Mission number 7 puts us in the reset game to defaults. So anytime we run our game, it looks like we're targeting that array of stars, and then we're using something powerful called a for loop. And it says let I equal 0, I less than star count. Well, what is star count? It's 70. So this is going, and then we're incrementing or increasing the variable I. So I is going to start at 0, this variable, then it'll be 1, then it'll be 2, then it'll be 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10, all the way till it hits like 67, 68, 69, and then it will stop because 70 is not less than 70. This for loop is going to run from 0 to 69. That's going to run 70 times. And each time, what are we doing? Well, we're taking this array or container that we have that's going to hold our star objects, and we're calling stars.push. So we're going to push something into this array, or push it at the end of the array. So right now it's empty, but after I run this the first time, we might have an array that has star 1 in it. Then the next time it will have star 2, and the next time star 3. And this will continue to hold all of our stars. And if we look, we're making these stars an object. Do you see how they're inside curly brackets? Just like the player was inside curly brackets. But here we have some different properties. We have an X property, which is random. So that means we're randomly going to place our stars from 0 all the way to the width of our canvas. So in the X direction, we're saying, hey, pick a random value from 0, the left side, all the way to the width of our canvas. In the Y property, we're saying, hey, randomly select from 0 all the way to the height of the canvas. So 0 starts all the way at the top, and we're going all the way down to the height of the canvas. All right. And then we have a size, and we're randomly selecting from our star min size variable and star max size variable that we had previously set. So I think our problem is in the Y direction. We're sort of creeping into the HUD. I don't want to start randomly selecting for star locations here at 0 because that's part of the HUD. So I have a variable called HUD height, right? It's in my student edit zone. If I we'll look way up here, I have HUD height right here set to 60. So we are going to set that range for mission number 7, our Y property. Instead of saying 0, let's be extreme. Let's do like, I don't know, 500 to height. All of my stars are down there now. So we don't want that to happen. So let's use that variable HUD height as our starting range. HUD height. All right, so that means now when we randomly create a star's Y value, it's going to only start picking from right here all the way down to the height. And no more stars are in our HUD. Hey, that's a huge success. I think there's only one more mission to do, and that is mission number 8. It's all about our HUD identity. So this puts us in another draw function. So remember, we can draw graphics to the screen. We can render graphics to the screen. In our draw scene function, we're calling draw background, draw player, and draw HUD. We drew the background. Hey, watch this. We can comment the background out. Get out of here, background. No, I'm not going to draw it. Oh, there goes my background. I don't want that. But it's just neat that we can make these quick little changes. Like, I don't like the player anymore. Get rid of the player. Comment it out. Boom. Wait, I thought I commented the player out. Why is my player being drawn? Oh, there it is. I just had to refresh the page. I was like, everything that I know about programming is broken. No, there we go. So I'll bring it back in. But then we call draw HUD. And our HUD we had established is a area in which we can display text to the screen. So let's quickly work through what we're doing here. We're saying, hey, no stroke. Give me a marker that is invisible so you do not see the shape that I'm about to draw. And then we're putting paint in our paint bucket, that transparent black color, HUD BG color. And then we are drawing a shape, a rectangle. Rectangles need 4 pieces of information. The upper left-hand corner of the rectangle, x coordinate 0, y coordinate 0. Boop, right up here. And then you need the width of the rectangle, which is going to be the width of our screen, and the height, which is our HUD height. Let's see if we're passing those in. The width of our screen and our HUD height. Perfect. Then we change the paint in our paint bucket. We say, hey, let's put a new paint in there. We're going to use text color, which is like a nice white color. We align our text, so we tell it how it's going to sit in our horizontal space, left align, and our vertical space, center. And then we set a text size. Like, let's change our text size. I don't know, let's be funny. Let's make it 60. Look at that. It gets bigger. That's looks pretty bad, though. So let's change it back to 18. But what we want to do is we want to change the game title, because right now it says game name, which is sort of lame. We got a cool name for our game. It's called Astro. And so we're going to call the text function to create a piece of text that is this size and is this alignment and uses this color that we had previously set. I'm going to set this string here as our first piece of information to say Astro Drift, the name of the game. Feel free to use it, or feel free to make it any name that you want. So what are these other 2 pieces of information? Well, if I refresh the page, I get Astro Drift. Those are the X coordinate and the Y coordinates of the string that you want to display. And they're based off of how you aligned them. So this X coordinate is the left side, and this Y coordinate is going to be the center vertically. So let's just change it. I don't know. Let's make it like 500 and 200. So where's this going to be? Let's just see if we can predict where X coordinate 500, Y coordinate 200 would be. X coordinate 500 pixels in from the left. All right, and that's going to put it right here, 500 pixels in from the left, and then 200 pixels down. So like, look, right here, the A is at this position. So watch what happens if I change the left alignment to be center aligned. So now it's going to position the center of this string, which is probably the space at 500 pixels. So right now, if I refresh the page, can I do it with an F5? We should see the space appear here. And look at that, the space appears there. So that alignment gives us a little bit of freedom and a little bit of control. I'm going to put it back to left align, and I'm also going to change these numbers because I just don't think that they work. I think it was 15 and I believe 25. And with that, I will test to see if our game is in a much better state, and it is. We have our world set, we have our stars set, our HUD looks great, and our player is becoming much more responsive. We now have tracking movement of our mouse for our thrusters. So imagine if I had my mouse over here and I click the mouse or I hit the space bar, I can fire thrusters this way, which will move my ship into the opposite direction. Hopefully out of the harm's way of an asteroid, not into another asteroid. Sometimes I play the game that way. But we did some really great stuff here in this video. Our world set, our player set, and we're going to continue to build on this momentum in our next video. So I will see you then.